Alright, so in this lesson, I'm going to discuss the fact that pointers, like any other variable, have memory addresses, and we're going to look into this in more detail. So, up until now, we have learned a lot about pointers. In the previous examples, I have used a special type of 16-byte RAM in each lesson to make it easier to understand how variables are stored in memory and how pointers work. I have also showed how pointers can be used to point at variables inside memory by containing the memory address of those variables. Now we need to consider something else about pointers. Pointers have to exist somewhere inside of memory also. That means whenever you create a pointer, it is given a place in memory just like any other variable. Let's consider the following code. Only for the sake of this lesson, we need to make some assumptions, and so I'm going to write them out so that we can go over them. So first of all, we're going to assume that the data type unsigned short int is only 1 byte in size, just for the sake of this lesson. We are going to assume that you need 1 byte to store a memory address. We're going to assume that our pointer PTR is going to reside in a single byte of memory. We're going to assume that the variable height will reside at position 8 in memory like we've done up until now. And we're going to assume that the pointer PTR will reside at position 4 in memory. Now don't worry, you don't have to remember all of that. The main point that I want you to understand is that a lot of what I'm showing you is for illustrative purposes only, to make things easier to understand, and not all of this carries over into actual real code, but don't worry, you will understand what does and what doesn't. So first of all, let's imagine how our memory is going to look. This is what RAM is going to look like, our 16-byte RAM. Okay, so at position 4 in RAM, we're saying that's where our pointer PTR is. Look at what is contained at this memory address. The value 8. Why? Because we are assuming that PTR contains the memory address of height. And we're assuming that height is here at position 8. So don't worry if this is confusing. Let's go over it carefully, one step at a time. First of all, we're creating height and giving it a value of 10. That means at the memory address for height, which we're saying is here, we have the value 10. That's all. Then we're creating a new pointer and giving that pointer a value which is the memory address of height. Now that pointer has to go somewhere, so we're assuming the pointer goes here at memory position 4, and we're giving the pointer the value which is the memory address of height, just like we've done up until now. Now, just to make this maybe a little easier to understand, I'm going to take away all the bytes that we're not using. So here first of all, we're creating the variable height. We're giving it the value of 10. Height has a memory address. That memory address we're assuming is position 8 in RAM, like we've done because it's easy to understand. And we're saying at position 8, there is the value 10. And then we're saying that we're creating a pointer of the same data type. Remember, the data type of the pointer is important in knowing how many bytes to move when you change the pointer, say add 1 to it, and it's also important because when you're looking at the data that is at that memory address, you need to know what you're looking at. But the pointer itself, any pointer, no matter what data type it is, a pointer contains a memory address, and a memory address is just a number. So we're creating a pointer and we're giving it a value, which is the memory address of height, and we're saying that that pointer is going to be here at position 4. So we're saying PTR is here in RAM at position 4, and PTR contains 1000, which is the memory address of height. That's what we're saying. And we're saying, whoops, height is here in RAM, contains 10, the value of 10. So with that in mind, I'll once again show you the whole thing. It should make more sense now, if you were confused before. Now, notice that our pointer is really no different than any other variable. It has a memory address, which in this case is 4, and it has a value, which in this case is 8. The value is just a number. It just so happens that that value, that number, is the memory address of the variable height. In an earlier lesson, we saw that variables like height are plain English names that correspond to values that are stored at specific memory addresses. For example, if I type height equals 10, C will keep track of the actual memory address where height resides so that I don't have to. Whenever you create a pointer, you are giving the pointer a plain English name the same way as you would do for a variable in general. And a pointer has a memory address just like a variable does. So all we are changing in this example versus what we've done so far is it used to be that I wrote something like this. I would say height is here, and then I would say PTR contains 1000 or 8, which is the value, which is the memory address of height, right? Now, all I'm doing is I'm reminding you that PTR is a variable. It's a pointer, but it's still a variable. It has to exist somewhere in RAM, so we're giving it an address. We're going to give it the address of 4 in RAM, and we're going to say that at that address is the value 8, which is the address of. So here, that's all we're doing, is we're clarifying that PTR is itself a variable, it has a memory address, and it has a value, just like any other variable. Okay, so a pointer and a variable are pretty much the same thing in this sense. So let's consider the following code. Here, we're creating a variable called height, and we're giving it a value of 5. We're creating a pointer called myPointer and giving it a value, which is the memory address of height. Now, after these 2 lines of code, we have learned that, first of all, if we write myPointer, then we are referring to the value that is stored in myPointer, and that would be a memory address. In this case, the memory address of height. So without the star, if we just write myPointer, then we are referring to the memory address of height. If we write star myPointer, then we are referring to what is at that memory address, which means we're referring to the actual binary sequence for the number 5. Now, a new question for you. What does this mean? Well, this means address of. So this would mean the memory address where my pointer, whoops, is in memory. So just like you can write ampersand height to mean the address of height, you can say ampersand my pointer to mean the memory address of my pointer. Just the memory address of the pointer, not what is stored there. In our 16-byte RAM example, ampersand my pointer would refer to this. Oops. The value 4, because what we, alright, make this a little more clear. Let me paste back what that looks like so you can see it. So this is our 16-byte RAM. So since my pointer, I'll just call it PTR. There. Let's look at it like this. So ampersand PTR, what does it mean? Well, PTR is a pointer that exists in memory at position 4. It contains the value 8, because 8 is the memory address of height, and so on, but we don't really care about that. All we really care about is that it has a memory address. Pointer has a memory address, which is 4. So ampersand pointer means the memory address of PTR, which in this case is going to be 4. So in summary, a pointer has to reside in memory somewhere, just like any other variable. You can use the ampersand operator, which means address of, with a pointer in order to obtain the memory address where the pointer itself resides. So, if I write here, I have created a pointer. If I write, now I'm referring to whatever the value that is stored in that pointer, which is presumably going to be a memory address. Like, let's suppose I created a variable called height, and I gave it the value 5, and I set this to the address of height. So here, my pointer is just going to refer to the memory address of height. If I write this, then I'm referring to what is at that memory address, which is going to be 5. If I write this, then I am saying the memory address where the pointer itself is. I don't know what that memory address is, but I know there has to be one because everything has to be in memory somewhere. So this pointer has a memory address. It exists in memory somewhere, and if I wanted that specific memory address, I would put an ampersand in front of the pointer name like this. We'll get into this more in detail later, but right now I just want you to understand two things. A pointer has a memory address, just like anything else. You can obtain that memory address with a ampersand address of operator. Okay, on to the next lesson.